Good morning, students. Welcome to chemistry class. Today we're discussing about the from solid state chapter. The subtopic is electrical properties. Electrical properties. Solid exhibit an amazing range of conductivities. Amazing range of conductivities. Extending order over the 27 orders of magnitude ranging from 10 to the power of minus 20 to 10 to the power of 7 per ohm per meter. Ohm inverse or meter inverse. Ohm inverse, meter inverse. So 27 orders. The ranging orders are 27. The magnitude is 10 to the power of minus 10 to 10 to the power of 7. 10 to the power of 7. So based on conductivity of the substances, mainly they can divide it into three types. One is conductors. One is conductors. So conductor means the conductivity ranging between 10 to the power of 4 to 10 to the power of 7 ohm inverse meter inverse. Then so the ranging between conductivity from here to here, that is called conductors. Another definition: the substances which are allow or conduct the electricity through them, that is called conductors. So for example metals. Whatever may be. Then another one is second one is insulators. The substance conductivity ranging between the 10 to the power of minus 20 to 10 to the power of minus 10 ohm inverse meter inverse. So the substance is called insulators. So another definition: the substance which cannot conduct the electricity, that is called insulators. For examples, wood, plastic, etc. Then another one thing is third one semiconductors. The substance conductivity ranging between 10 to the power of minus 6 to 10 to the power of 4 ohm inverse meter inverse. So the type of substance are called semiconductors. For example, silicon and germanium. Generally, silicon and germanium shows the semiconductors. So in this can apply the heat, the conductivity will be increases. Here also more temperature will applicable to here. This is also can act as sometimes conductors. But when increase the electricity temperature here, the conductivity will be disorder, so not conducted. So that's why these, in the application of temperature applicable to this one and this one, that can be converted into conductors. Then here we'll see now conductivity in metals, conductivity in metals, conductivity in metals, conductivity in metals, metals. So generally conductivity in metals, conductivity in metals, the conductivity electricity in metals generally where the free electrons available are ions, that is responsible for the electricity, conduct electricity, electrons or ions, ions. So these are responsible for the conduct electricity, conduct electricity. Where we will show in metals having atomic orbitals, atomic orbitals, atomic orbitals, atomic orbitals converted into molecular orbitals, converted into molecular close together, and they can overlap with the atomic orbital to form a molecular orbitals, molecular orbitals. In this molecular orbitals when formed, these orbitals can close to each other to form a band, to form a band. So to form a band. So that band having some of the having filled electrons or partially filled electrons, that can be conduct electricity. That band conduct electricity. So here the energy barriers between them large is there, that do not conduct electricity, So that is called one of the band theory. So here in metals, the partially filled electrons, this is band, partially filled electrons, these are electrons are filled here, this is empty space, this is empty space, this is filled electrons, filled by the electrons. So can jump to empty space, at that time that can be easily conduct electricity, that can be electricity is easily conducted. Then another thing is if maybe higher energy band and lower energy band that having filled electrons, this is overlap, empty conduction band overlap with the, this is valency band, this is conduction band. So conduction band when overlap with the valency band, overlap with the valency band easily, that electrons from shifted to lower to higher. So when the gap between valency band and conduction band, so no gap between them, so at that time they can act as conductors, So this is filled, this is empty, this is filled electrons, this is empty electrons. Then another thing is in semi insulators what happen, the conduction band between larger gap between the conduction band and valency band is more, what happened, that cannot be easily electron jump from valency band to conduction band. So this zone is called forbidden zone. So this is filled electrons, this is empty, so this is conduction band, this is valency band. So electrons cannot jump easily from valency band to conduction band, right? Because the gap between is larger between them. So that's why That's why it is not a this type of band not conducted electricity. So this is we have to say in insulators. In insulators. Insulators. Insulators will observing in insulators will observing valency band and conduction band. Between them, the larger gap larger gap between them. Then another one is in semiconductors. Conductivity in semiconductors. What happened in semiconductors? In semiconductors, in semiconductors, so conduction band, this is conduction band, this is a valency band. So gap between them is less. So small. This is very small. This is very small, and here small gap between conduction band and valency band. So the electron jump some of easily to the conduction band. So not all. Why? Because some gap is there. So that's why this conducts a little bit electricity. So that is called here semiconductors. Then semiconductors, when increase the electricity, what happened? This when increase the temperature, that electrons absorb the energy can move from valency band to conduction band. Then increase the conduct electricity. Then here suppose when adding extra elements to the semiconductors, what happened? That gives other converted into conductors. Or increase the conductivity of the electricity. So that any another foreign element adding to the semiconductors that can be increase the electricity, conductivity in them. So that adding the element is called impurity adding is called doping. Doping means the impurity added to the semiconductors to increase the conductivity of the electricity. That is called doping. So doping two types. One is electron rich doping. Another one is electron deficient doping. Electron rich doping and electron deficient doping. Generally, we'll observe semiconductors. The semiconductors. What is the semiconductors? What are they? Silicon and germanium. So silicon and germanium, which group? 14th group. Which group? 14th group. So outermost electron configuration is ns2 np2. The structure of silicon, maybe observe this structure of silicon. So each silicon having 4 electrons around it. Means why? Because they have which type, how many electrons in valency? 4 electrons. So that's why that have bonds like this. bonds like this. Each bond having how many electrons? 2 electrons. Each bond having how many electrons? 2 electrons. Each bond having how many electrons? 2 electrons. 2 electrons. So here, this is suppose observe 1, 2, 3, 4 electrons, and this is 1, 2, 3, 4, like this 4. So all this is also 1, 2, 3, 4, like this. So 4 electrons around the silicon. 4 electrons around the silicon. So in electron rich elements can add it to this. Electron rich elements means generally we have to applicable to electron rich here 15th group elements. 15th group elements. So 15th group elements. Phosphorus, like phosphorus and arsenic. Phosphorus and arsenic. So what is the electron configuration in outermost shell? Ns2np3. Ns2np3. So in outermost shell, how many valence electrons are there? 5 electrons. 5 electrons. So when adding arsenic to this what happened? So silicon, arsenic, silicon, so is having around 4 electrons, 4 electrons, so here 1, 2, 3, 4 electrons. 1 is remaining. 5 electrons in outermost generally. So 5th electron is here. 5th electron is here. So remaining like this. One bond is here. Bond. So bond all are remaining 4 electrons. So this is having 5 electrons. So one is extra. N is extra. So this gives electron rich. This gives electron rich semiconductor. Means this gives n-type semiconductor. Why? Because negatively charged semiconductor. Why? Because electron is a negatively charged semiconductor. So this is n-type semiconductor or electron rich doping to the semiconductors of silicon and germanium. And another one is electron deficient elements doping to the semiconductors. What happened? Silicon, that is here we have using 13th group elements. So 13th group elements like boron, aluminium, gallium. So what is the electron configuration in outermost Ns2 np1. Means 3 electrons in outermost cell. So 3 electrons in outermost cell. So what happened? This is doping to the silicon. What happened? So silicon having around the 4 electrons. Boron having 3 electrons. Then boron having 3 electrons. So what happened is it gives a positive, that they have one positive pole. Only 3 electrons. This is having 4 electrons. This is having 4 electrons. This is having 4 electrons. So bond formed, and this is also having 4 bond formed like this bond. Then like this. like this. So no electron here, so that's why here they have a positive pole, a positive pole. So that's why this type of electron, this type of semiconductor is called p-type. P-type semiconductor. P-type, they have a positive pole. So this positive pole, this electron is there. Electron when adding to this, when adding, or this electron when adding to here, what happened? Electron flow from here to here there, and the current, the flow of the current in opposite direction of the, from the opposite direction from the electron. So electron current flow like this. When electron shifted to like this, what happened? Current will be opposite direction. The forward, the electricity can flow with opposite from the electron flow. So this is p-type semiconductor. P-type semiconductor, or that doping is called electron deficient doping. Then, so this gives doping of electron deficient gives n-type semiconductors. Doping of electron deficient element, that gives what? P-type semiconductor. P-type semiconductor. Then applications of semiconductors. So applications. So generally semiconductors we have to using so many uses are there. So for making diodes, maybe photodiodes, whatever it may be. Then another one is transistors, and so we have to use mainly this, and you may read in briefly that applications also in the textbook of NCERT.